Hello class, today we're going to talk about section 7.3, which is scientific notation. By the end of today's lesson, you'll be able to write numbers in scientific notation, get them out of scientific notation back into standard form, and learn how to multiply and divide these numbers using their exponents. So, scientific notation is a way to write very large or very small numbers. So those that would contain a lot of zeros, for example, like 3 trillion, would have a ton of zeros at the end, so it's a lot easier for us to write 3 to a power. So our format here is going to be a times 10 to the nth power. The a value needs to be between 1 and 10. It can be equal to 1, so greater than or equal to 1, but it has to be less than 10. If it's equal to 10, that means we need to move the decimal place one more place farther to get it back down to 1. The rule for the exponent is that it has to be an integer. So that is a positive or a negative whole number. There are no decimals involved in our exponents. So, for example, we've got our first number, which is 201 million. So our first job is to find a place to put the decimal so that our number is between 1 and 10. So if I look at a place to put the decimal, I can put it right here, and that's going to give me a number of 2.01. We don't care about the rest of these zeros. We'll get to that in a second. But our number here is 2.01. That's between 1 and 10. So we're going to say times 10. Now, since we added in a decimal place, we need to know exactly how far we moved it, because the decimal of our number technically started at the end. So we moved it 1, 2, 3, 4, 5, 6, 7, 8 spaces. Since we moved it 8 spaces, that would mean in order to get back to this number, we need to move it back 8 spaces. So, since we've got a large number, we've got 2.01 times 10 to the 8th power. Another way, sort of a shortcut that you can use to think about this, is counting up your zeros. So I had 6 zeros, and then counting up the number of decimal places in our number. So that's 2. So I had 2 decimal places plus 6 zeros gives me that exponent of 8. Now, if we're looking at this smaller number down here, 0.0000051, again, we want to put our decimal place in somewhere that's going to get us between 1 and 10. So now, my decimal is 5.1. I need to, again, count how many places it was. So I've got 1, 2, 3, 4, 5 places that I moved it. Since we want the zeros to show up in the front of the number now, we are going to use a negative exponent. Again, you could count your zeros and say there's 4 zeros, and then there's 1 extra place to get to the new decimal, so we have -5 for our scientific notation. So when we have big numbers, our exponents are positive. When we have decimal numbers, our exponents are going to be negative. Go ahead and try this one on your own. So we put in our decimal place to get somewhere between 1 and 10. Counting up our spaces, I've got 1, 2, 3, 4, 5, 6, 7 zeros, and 1 extra space gives me a -8 for an exponent. If you have questions about converting numbers into scientific notation, let me know when you get to class. Our next job is to get them from scientific notation back into what we call standard form or numerical form. So we've got 6.32 times 10 to the 9th power. So what that is saying is we need to move our decimal and we need to go 9 spaces to the right since it is positive. So 1, 2 gets me to the number 632, but I need to move a total of 9 spaces, which means I need 7 more zeros on the end. It might also be helpful at the end to plug your commas back in so you know exactly where your numbers are at. On the flip side, this one, we've got 4 times 10 to the -7th power. That means since it's a negative, we're going to be adding those zeros in front. So we are moving to the left. So I'm going to start my 4 over here, and then I'm going to go 1 decimal place to get it in front of the 4, 2, 3, 4, 5, 6, 7, and that's where I'm going to put in my decimal. And then I'm going to go ahead. We always want to make sure that there is a number in front of our decimal point. So I'm going to put in that 0 point for our final answer. So we've got 0.00000004. Go ahead and try this one on your own. So we moved 3 spaces to get rid of the decimal, which means we need to add on another 4 zeros and then throwing those commas in at the end. If you have questions about getting numbers back into standard form, please let me know when you get to class. Last thing we're going to do here is talk about multiplication of our numbers in standard form. So what we want to do first is multiply our a values. So this 6.5 times 8.7. When I multiply those, I'm going to get 56.55. Then I've got times 10. Now we're going to follow our product rules for multiplication. So I've got 12 plus negative 15, which is going to give me an answer of negative 3. So we've got 56.55 times 10 to the negative 3rd power. There is something wrong with that answer. The issue is our number in front, 56.55, is not between 1 and 10. So what we need to do now is we need to move our decimal so that we can get it between 1 and 10. So that means I'm going to have to move it 1 decimal place to the right. So I've got 5.655 now times. Now we have to deal with our exponent. We have to figure out what that movement did to our exponent. This negative 3 is telling me to get it back into standard form, I should have moved 3 places to the left. This movement to get our number to be between 1 and 10 already moved it 1 space to the left. So what that means for us is we only have 2 spaces to go to the left still. So since we were decreasing our number, that exponent went up. Go ahead and try this one on your own. So when we multiply our numbers, we get 17.5 times 10 to the 2nd power. We moved our decimal 1 place over again to make it between 1 and 10. And once again, that means that our exponent had to go up. So now, since I would have moved it 2 spaces to start, now I have to move it 3 spaces since I have an extra place to the left now. If you have questions about this, please let me know when you get to class. Last thing we have to discuss is the division of numbers in scientific notation. Again, you're going to start with your a values. So I've got 3.066 divided by 7.3, which gives me 0.42. I'm going to follow my quotient rules now for my exponents and subtract. So I've got 8 minus 3, which gives me 10 to the 5th power. Again, my a value is not between 1 and 10, so I'm going to need to do something to fix that. I'm going to move the decimal point 1 place to the right. So I'm at 4.2 times 10. Again, we need to figure out what to do with our exponent. Since we already moved 1 place to the right, and we were supposed to move 5, that means I have 4 places left to move. So if you move that decimal point to the right, you're going to be decreasing your exponent. Go ahead and try this one on your own. Dividing gives you 0.9 times 10 to the 7th power. 3 minus a negative 4 is going to give us 7. We moved our decimal 1 place to the right to get from 0.9 to just 9, which means our exponent is going to decrease by 1. If you have questions about this, please let me know when you get to class. Last but not least, we have a word problem. So we've got a satellite radio company earns $125.4 million in a year, Write this number in standard form and in scientific notation. Then if the company earns 2.5 times the amount next year, determine the amount earned and write in scientific notation and in standard form again. So first we're going to deal with this year, and we are looking at 125.4 million. So if I've got 125.4, if I want to turn that into millions, I need to add in some zeros. So that gives us our 125 million. The 0.4 then means it's in the thousands. So I'm going to take this and turn it into scientific notation now. So 1.254 times 10, and then I need to count up my zeros. So I've got 5 zeros and 3 decimal places for a total of 8 in my exponent. So the next thing it asks us to do is multiply it by 2.5. So I'm going to go ahead and multiply my bases, and that's going to give me 3.135. There's no base on the 0.25, so I still just have times 10 to the 8th power. And then I need to turn that back into standard form. So I'm going to move it 1, 2, 3 spaces to get rid of the decimal, and then add on 5 zeros on the end, putting in my commas to give me 313,500,000. If you have questions about the word problem or anything else from the lesson, please let me know when you get to class.